All right, let's open up a cosmic cold case file. The mystery? Well, it seems the universe is hiding something from us. There are these structures out there, as massive as entire galaxies, but they're almost invisible, like ghosts in the cosmic dark. So today, we're going on the hunt for the universe's missing galaxies. But before we go charging into the unknown, we've got to start with a really basic question. What is a galaxy, anyway? I mean, we've all seen the incredible pictures, but what are we actually looking at? The textbook definition is pretty simple, right? It's this giant city of stars, gas, and dust, and it's all held together by the incredible gravity of something we can't even see, which we call dark matter. For a long time, the main thing we looked for was the stars. They were like the streetlights, you know? They let us know a galaxy was there. But that's the heart of the whole mystery. What if you've got all the other parts, the incredible mass, the gravity, the gas, but the stars just aren't there? What if the city exists, but every single light is out?
This brings us to our prime suspect. It's a theory that's been the king of cosmology for something like 40 years. And for a while, we thought we had it all figured out. But now there's new evidence coming in that's casting some serious doubt. The case against our prime suspect is building. And that suspect is called cold dark matter, or CDM for short. This is the standard model. It's the idea that dark matter is made of these heavy, slow-moving particles. And look, to be fair, it's been amazingly good at explaining the really big picture, why galaxies clump together in these huge clusters, forming this vast cosmic web. On a large scale, it works brilliantly. The problem is, when you zoom in, the alibi starts to get some holes in it. Astronomers call this the small-scale crisis, and it's basically a list of nagging problems. First up, you've got the missing satellites problem. CDM predicts our Milky Way should have hundreds of little galaxies buzzing around it, but we can only find a few dozen. Then, there's the Cusp-Core problem. The model says a galaxy center should have a really dense spike, a cusp, of dark matter. But when we look, we often see a much flatter core. And finally, the too big to fail problem. The theory says the biggest dark matter clumps should always be great at making stars, but we find lots of them that are surprisingly dim. It's like a suspect whose story sounds perfect from a distance, but the closer you look, the more it falls apart. And that's when our cosmic detectives, our astronomers, started finding some very weird new clues. The first piece of evidence that really messed things up was a whole new type of object, the Ultra-Diffuse Galaxy. Let's call this Exhibit A.
Okay, let's pull up the case file for Dragonfly 44. When this thing was found, it was a total bombshell. Here was an object about the same size as our own Milky Way, and the first measurement said it was just as heavy. But, and this is the crazy part, look at the stars. It had only 1% of the stars of the Milky Way. The conclusion was just staggering. This galaxy seemed to be 99.99% dark matter, a true cosmic ghost.
Now, this is a perfect example of how science really works. More investigation, specifically by doing a recount of its star clusters, brought that mass estimate down. So Dragonfly 44 wasn't a dark Milky Way after all. It was more like an incredibly puffy dwarf galaxy. But here's the key thing. The case didn't get thrown out. It proved that these huge, incredibly faint, dark matter-packed objects were actually out there, hiding right under our noses.
And once astronomers knew what they were looking for, well, the mystery just got deeper and deeper. They started finding things that were even weirder, even more extreme than Dragonfly 44. They started finding galaxies that had no stars at all.
So check this out, J0613 plus 52. And get this, it was found completely by accident. A radio telescope was just pointed at the wrong spot in the sky. And what did it see? A giant, spinning cloud of the original hydrogen gas from the Big Bang, the raw fuel for making stars, but with absolutely zero stars detected. It has the mass, it has the spin of a galaxy, but it's totally dark. It's a galaxy that never even got started.
So why? Why would it just sit there for 13 billion years and do nothing? Turns out there are two reasons. First, its gas is just too spread out, too diffuse to collapse in on itself. And second, it's a cosmic hermit. It's so isolated from any other galaxies that it's never gotten a gravitational push from a neighbor to get the whole star-making party started. It's basically a fossil from the dawn of the universe, completely undisturbed and undeveloped.
And there are more. Astronomers then found this thing called Cloud 9. It's another nearby cloud of hydrogen gas that is, for all intents and purposes, a failed galaxy. It's a dark matter halo full of gas that just never managed to flip the switch and turn its stars on. You see? These are exactly the kinds of objects that could solve that whole missing satellites problem. They're here. They're just dark. So, all this evidence was piling up, and it was pointing to some major problems in the Standard Model. But then came the smoking gun. An object so bizarre, it might force us to completely rewrite our theory of darkness.
Meet Nube. That's Spanish for cloud. It's a dwarf galaxy, but it's way too big and way too faint for its size. And here it is, the key anomaly. Its stars are spread out in this incredibly flat, uniform way. It has a diffuse core. It completely contradicts the dense cusp that cold dark matter says should be there. Our computer simulations, the ones based on the Standard Model, they just can't make an object that looks like this. It shouldn't exist.
So, if our prime suspect, cold dark matter, can't explain the evidence, we need a new one. And that's where fuzzy dark matter, or FDM, comes in. This theory is wild. Instead of dark matter being a heavy, slow particle, what if it's an incredibly ultralight particle that acts more like a wave on cosmic scales? It's a simple change, but oh man, it has huge implications.
You see, because these FDM particles are so unbelievably light, their quantum wavelength, the space they take up, stretches for thousands of light years. That natural wave-like behavior physically stops them from piling up into a dense cusp at the center of a galaxy. Instead, quantum mechanics itself naturally creates a diffuse, fuzzy core. And that fuzziness, it just so happens to perfectly explain the strange, puffy structure of a galaxy like Nube.
As astrophysicist Ignacio Trujillo said, if this is right, it would be a demonstration of the properties of quantum physics, but on a galactic scale. Just let that sink in for a second. The bizarre rules of the quantum world, the stuff that governs subatomic particles, playing out across an entire galaxy. It's just one of the most incredible ideas in all of cosmology.
But the case isn't closed, not by a long shot. The discovery of these cosmic ghosts has thrown the doors wide open for a whole new investigation. Really, the hunt is just getting started.
So, what's next? Well, we have these amazing new clues from Nube and JO613. And soon, the Vera C. Rubin Observatory is going to begin a 10-year scan of the sky that will give us the first complete map of this faint, hidden universe. At the same time, the Euclid Space Telescope is going to map the dark matter skeleton of the cosmos directly, searching for these dark halos, whether they have stars in them or not.
And that leaves us with the final, massive question. Are these ghost galaxies just a few weird outliers, the exceptions that prove the rule? Or are they the first real glimpse into a universe where the very nature of darkness isn't cold and hard, but is fundamentally fuzzy? The evidence is building, and whatever the answer is, it's going to change everything we thought we knew.